Welcome to this S2 past paper walkthrough. Let's start with the first question here. So you can see a shop sells shoes at a mean rate of 4 pairs per hour on a a weekday. So if you've got a rate, if you've got this word, rate, that's an indication that this is a Poisson distribution, where lambda equals 4. Okay, so part A here suggests a suitable distribution model for the number of sales pairs of shoes per hour. So always check that it's the same per hour, so it's just going to be the same. So this is going to be, X, or a random variable, whatever letter you want to use. Poisson, lambda is 4. Part B. Now, state one assumption necessary for this distribution to be a suitable model. So it's just, so that was A. Pairs of shoes, that's what we're looking at, aren't we? Are sold. And then it's kind of any of your singly. I don't know if I spelled that right there. Singly or independently. Randomly. Something like that, yeah? So pairs of shoes are sold singly at an average rate. Okay, but it's important because it's singly is important. It's not that someone's coming in and buying several pairs of shoes. It's that everyone's coming in and they're just buying each pair of shoes, And independently, they're not dependent on something else. So those are the things. They're actually, just stated in your textbooks. Some of the assumptions that are necessary. So you just need to learn them. Okay, have a little look in your books. Okay, part C. Find the probability that on a weekday the shop sells more than 4 pairs of shoes in a 1 hour period. So, probability that X is more than 4. So first then write it in terms of, so you've got it with an equals. So more than 4 means greater than or equal to 5. Okay, and then greater than or equal to 5 would be 1 minus the probability that is less than or equal to 4. Okay, so that's the steps, the process to make sure you never make a mistake on these. Turn it into an equals, and then if it's a greater than, then you can switch it to the less than with your 1 minus. So that means we've got 1 minus. Now you need to go into your stats function, your distribution function, and your calculator. X will be 4 and lambda will be 4. And that will give me 0.6288. Okay. If you are going to do it in, sorry, just finished tapping off. If you're going to do it in the tables, then here's the section from the tables. We can see there's the 4, and it's 0.6288. So you can look it straight up in the tables, your lambda, and obviously go across to the 4 in this top bit. Okay, so that's how it is with the tables. Now, part 2 here is more than 4 pairs of shoes in each of 3 consecutive 1 hour periods. So we've got the probability of getting it in 1 hour. Then if it's going to be in consecutive hours, then that's got to be, the probability of greater than 4, and the probability of greater than 4, and the probability of greater than 4. So it's going to be 0.3712 cubed, because it's going to be that probability times by itself times by itself. Okay, so 0.0511, to say 3 significant figures there. Okay, now we're on to the final bits. We've got the area manager visits a weekday, day of so an advert in the shop appears. When appear, they sell 7 pairs of shoes. So the manager believes that the advert has made the shop sell those pairs of shoes. So this is now an hypothesis test. So 5% significance level, whether or not there's evidence of an increase in sales. So we're purely looking for whether there's evidence of an increase. So it's going to be a one-tailed. So the 5% is important and the increase there is important. Yeah. So when I'm looking at this, my H0 is lambda equals 4, and my H1 is lambda is greater than 4. Okay. And now you can do this kind of 2 ways. So we can go, right, what's the probability that X is what? We're looking at the 7 really, but so we're looking at greater than or equal to 7. So that would be 1 minus the probability that X is less than or equal to 6. 1 minus, now I'm just going to look over in the tables here. There's the 6, I've just highlighted it yellow. So 0.8893. Of course you can get this value from your calculator as well. But since I had the table right there, I might as well use that table. So here this is like 11%. It's obviously not less than that 5% that we need. So we can say that 0.1107 is greater than 0.05. Therefore, we do not reject H0. Or you can say accept H0. It's up to you how you want to go about that. Alternatively, you could look for the critical region. Okay, so if I'm looking for my I'll put this in blue here, critical value first. Yeah. Then because we're looking at the top end, will be the 5%, so we'll be looking at 0.95. So here, if we have a look, and I'll highlight this one in red in the tables, we're looking at 0.95. So we'd be looking at, say, these 2 values here. Okay, so we're always kind of one or the other. If I want to write this out, so as it stands, sorry, I didn't have a pen on them. Probability that X is less than or equal 7 is a 0.9489. Now that's not going to be less than the 0.05, but I'm just going to show you anyway. So this would be, 1 minus the probability that X is greater than or equal to 8. And then if you rearrange, this would give me 1 minus that, so 1 minus 0.9489, and this is 0.0511. Okay, then if I look at the next one, so the next one is, probability that X is less than or equal to 8 is your 0.9786. So doing the same again, 1 minus, so we're going to get probability that X is greater than or equal to 9 is 1 minus that, so 1 minus 0.9786, and there we have 0.0214. So this is now the critical region here, 9. So if we worked out the critical region first, instead of like from here we can say that it's not in the critical region, therefore do not accept. So rather than this bit, where I can compare to the 5%, I would say it's not in the critical region, do not accept. Now, either way, when you work out that it is or it isn't, and you start your initial bit where you're saying you're accepting or you're not accepting, you must always then refer it or rewrite it in terms of the question. That's always your final step. I like to kind of generally take the words from the question, but so you'd want something along the lines of there is, in this case, insufficient evidence to suggest that there has been, so he thinks there's going to be an increase in sales. So insufficient evidence suggests that there has been an increase in sales due to the advert in the newspaper. You don't really need that end bit, but just take the words from the actual question, So anyway, you want, so he believes that the advert has increased the shop sales. So you just want to say it's insufficient evidence to suggest that the advert has increased shop sales. You could just literally write this part here, that the advert has increased shop sales of pairs of shoes. Okay, dead easy. Okay, question 2. We've got a bag contains a large number of coins, only contains 20s and 50s. Random sample of 3 is taken. List all the possible outcomes or combinations. So nothing too difficult about this, is just listing them. So 20, 20, 20, 20, 20, 50. I sometimes do these in little sections, So, I've got 20, 50, 20, and 50, 20, 20. And then we've got 2 50s to add, so 20, 50, 50, 50, 20, 50, 50, 50, 20. And then we've got 3 50s, haven't we? 50, 50. So you got 1, and then it's 3, 6, and another one. So we've got 8 in total. Now here is let X represent the mean of the 3 coins below, and this is given. We've got to work out A and B. So nothing again too difficult here. A is, well, it's this type, isn't it? So 2 20s and a 50. So as its average, just want to add those up. So 20 plus 20 plus 50 is 90. 90 divided by 3 is 30. So that's 20 plus 20 plus 50 over 3. So that there is A. Let me put it's A there. So what I want to also, in fact, let me just rub this out a second. There we are. Let's pop it in there properly. So B now is going to be 20 plus 50 plus 50 over 3. So that is, it's 120 over 3, so that's going to be 40. Don't know why I keep on putting the things around it. So there's that part of the table filled in. Now, next we need to work out the probabilities of each of these. So for this one, this first one here, A, it was this section, wasn't it? 2 20s and a 50. So the probability of getting 2 20s and a 50. Sorry, I'm getting a little bit ahead of myself then. That was just find A and B, wasn't it? There's a bit more information to come. So the probability of taking a 20p coin is P, and the probability of getting a 50p coin is Q. Find the values of P and Q. Wonder why it's labeled C and D there, and then P and Q. Oh, so P and Q is not part of that, right? Okay. So probability of taking a 20p coin at random is P, Q. So the probability of taking, let me see. All right, sorry, I'm just trying to think there. So from the information, so we got C here. So P is the 20p one. So P cubed would be this. Now that's because this is from the 20 times 20 times 20, yeah, the P cubed, and it give me this. So if I take the 4913 over 8,000 and cube root it, I get 17 over 20. And it should be easy from here because obviously P plus Q has got to equal 1. Those are the only two options. So I can quickly say that Q is going to be 3 over 20. But I'll just write in blue here the alternatives. So we're looking at Q cubed will be 27 over 8,000, which is 3 over 20. So that is P and Q done there. Sorry, I've done a little bit of a, I don't want to be writing that, so I should be writing P equals 17 over 20, you know, not leaving it alongside the P cubed, as that would just be essentially some bad maths. Right, hence find the value of C and D. So finding C is this section, the 20, 20, 50. So it would be P squared times Q, and that times 3. That's what we're looking at. Okay, so 17 over 20 squared times 3 over 20 times 3. So just popping that into my calculator. 17 over 20 squared times 3 over 20 times 3. So we get 2601 over 8,000. That's 2601. Pop it in there, and then the other one, so that was C. D would be 120 and 250s. And it's times 3 because there's 3 different combinations, you know. So we got 17 over 20 times 3 over 20 times 3. So that is 459 over 8,000. They're all over 8,000 there, so you just do a quick double check by adding up all the top values and making sure they add up to 8,000, and they do. So we know we're right. So here we got now, final part, let M represent the mode of the 3 coins. There we are. Find the sampling distribution of M. I'll just make a little bit more space. So For the mode, it's going to be a little bit different. There's only going to be two possibilities, 20 or 50. So if we have a table, just going to do a rough table here. So 20 or 50, because when you pick the three coins out, yeah, there's not going to be no mode. There's always going to be at least two coins of one type, yeah? So for the 20, we're looking at, when you've got 20, 20, 20, and when we've got two 20s and a 50. There's obviously three of those. That's what we're looking at as a mode of 20. So for that, we've got to work out the probability. Now it is going to be this one, isn't it? Because that's two 20s and a 50, and this one. So we're going to need to add these two values together. So 4913 plus 2601. So just in your calculators, 4913 plus 2601, 7514 over 8000. So 7514 over 8000. Now, if I minus 8000, that's what I would now expect to have as my other value. So mode of 50, and we're looking at 459 plus the 27. So 459 plus 27 is, as you guessed, 486 over 8000. And then in here is just going to write our probabilities. It's going to be m equals m. And there we have that last little bit. Okay, nice and easy, because we had all the values that we needed. There's actually very little working out. So here we have Super Bounce, manufacturer tennis balls. So from this, 10% of his balls fail a bounce test. It's quite a high percentage. Find the probability that from a random sample of 10 of these tennis balls, at least 4 of them fail the bounce test. Now, this is pass or fail, isn't it? Two different sets. We've got a set probability here of 10%. So this is crying out as a binomial problem. So let's set that up. So I'm going to use x again, and it's binomial. Now NP, so n is 10, isn't it? And p would be 0.1. Okay, so in terms of, if I just move this down a second, in terms of what x is, it is nice to kind of write what these things. So let x be the number of tennis balls that fail the bounce test. Okay, and of course you could change it to be the number of tennis balls that pass the bounce test, and then you'd have your percentage at 90%. So at least 4. So this is probability that x is greater than or equal to 4. So 1 minus the probability that x is less than or equal to 3. And then going into your calculator, so you want to go to your menu, distribution function, scroll down, and then you've got your binomial CD, and then click on variable, And then x is 3, n is 10, and p is 0.1. And it's quite high, 0.9872. I've missed the 0.1, the 1 minus. 1 minus, that's better. So in my calculator, I just often hit store it as a 1 minus alpha. So 0.012795 and so on. So we'll do the 3 significant figures here, so 0.0128. And that was the first part of A. Part 2, more than 1 but fewer than 5. So probability that more than 1 but fewer than 5. So if I rewrite that, that would be like this, wouldn't it? So fewer than 5, so it has to be at least up to 4 as a maximum, and more than 1, so it's 2, so it's between 2 and 4. So that is then probability that x is less than or equal to 4 minus the probability that x is less than or equal to 1. Okay, because we want between 2 and 4, this is going to be from 4 all the way down to 0. And then we're taking away from 1 to 0, and that'll leave us from 4 all the way down to 2 then. Okay, so again now, just want to go into distribution function, pull down binomial if you didn't already have it up. So we got 4, 10 and 0.1. Now I'm going to store this in my calculator. I think it's the same value from earlier, you know, the 0.987. No, earlier was 3, wasn't it? So it's actually right 9983. 65 minus 0.736099. I'll store that one as B. So these are like, when I'm in my calculator, I am storing them as these letters, and often I put the letter next to my calculation so that I can remember that's what I've stored it as, because sometimes I got a few on the go. So in this case then I just need to do alpha A times alpha B in my calculator without having to write anything back into it or any of the big numbers, so I can keep everything, you know, the full value of the calculator. So 2622661 and so on. So this is going to be 0.262 to 3 significant figures. Always better to do like a line where you give more of the values and then do your rounding, and then you can't kind of get anything wrong if you didn't round to a sufficient amount. Okay, now before I go on to the next bit here, I'm going to make a little bit of room. Okay, so the manager director makes changes to the production process and claims that these will reduce the probability of the tennis balls failing. Changes a random sample of 50 were tested. Sorry, I'll just highlight these now in red. So we got 50 were tested and found that 2 failed. Test at the 5% significance level, whether or not this result supports the manager director's claim. So his claim is that, what is his claim? That the changes would reduce the probability. So we're looking at H1 being a less than. So it's a one-tailed test again. So our H0 is going to be the probability equals 0.1, and H1 probability is less than 0.1. So a one-tailed test. And let's call this one Y. It's going to be between 50, and the probability is still assumed to be the same. So it's not X, is it? Y is less than or equal to 2. So this probability is 0.1117. Does carry on there, but we'll do that to 4dp here. I don't know why I'm switching between 3 significant figures and 4 decimal places. But yeah, so that's 0.1117. So this is not less than, it is greater than 0.05. Therefore, it's we don't reject H0. So accept H0. So do not reject H0. However you want to say it. Now remember, after this you always need to compare it back to the question. So there is insufficient evidence to suggest that. Now let's have a look into here. So he makes changes to the process and claims that these changes will reduce the probability. So it's insufficient evidence to suggest that the changes to the process reduced the probability. Sorry, my spelling is terrible. I really got to concentrate to spell, you know. So reduce the probability of its tennis balls failing the bounce test. And yeah, I'm just reading from here. Okay, and that covers that. Now let's look at the final part of this question, and for that I will definitely need some more room. Give me 1 second. And we're back with more room. Lovely. So let's set things up for this last bit. So we've got here is the second random sample of n. We don't know what n is. As a result of this sample, the manager-directed support claim is supported at the 1% significance level. I can get all my words out then. So let's, I mean, I've used X, I've used Y. I want to pick a different letter, maybe keep one of the other letters. Let me just chuck a random R for random. Binomial, it's n and 0.1. That's what we're looking at. Maybe R's not the best letter to use. I can't really think of another letter. Normally X, Y, Z. Maybe I'll use Z. Let's use Z, shall we? Nice. Right, so that's what we've got as a distribution. We know that H0 is 0.1 and H1, sorry, let's forget the P equals there. P equals 0.1 and H1 is P is less than 0.1. We know that that is accepted, don't we? So for this, we want to find the smallest possible value of n. Also, we need a little bit more information now in here from that none failed the bounce test. So that would have been a X equals, sorry, not an X, is it? It's a Z equals 0. That's what we're looking at, and we're looking for 1% significance level, so the sig level is 0.01. So we want something less than 0.01. Okay, so this is going to be the NCR. That's going to just be 1 anyway, isn't it? 0.0, so 0.1 would be, it's just essentially going to be 0.9 cubed, isn't it? You know, when we're looking at our NCR, you know, we don't know what n is, but that r is 0, isn't it? 0.1 to the power 0, 0.9 to the power n. So what we've got on that's going to be less than 0.01. So we've actually got 0.9 to the power n is less than 0.01. And then we have to go to logs. So we're going to take logs of both sides. Doesn't matter what base you use, as long as you use the same one. And then bring in our n down using the rules within our logs. And then we want to divide by this log 0.9. And this is where we have to be a little bit careful, because log of, now if you take obviously logs, you can't take logs of a negative number. Yeah, just try to calculate if you're not sure, but you can't take logs of a negative number, that's impossible. Logs of a number that is between 0 and 1 is always going to give you a negative value. So if you divide by a negative value, then it's going to be changing your sign and your inequality. So you just need to be careful with that there. So we've got now log of 0.01 divided by log of 0.9. So we got n is greater than 43.709. Therefore, n is equal to 44. That is the smallest value of n that works. Okay, hope that one wasn't too bad for you there. Before we start this question, I just want to remind you to hit that subscribe button if you haven't done so already. If you enjoyed the video so far and you find it useful, hit a like, and any questions, comment down below. I do try and get to everything, although some do kind of slip through the net, but I do my best to try and answer most of your questions. Now then, we have a continuous random variable probability density function shown here. Find that when x is less than 10k. So if you think of this, you know, I'm going to put it on the diagram, but you think it's basically going to be, you know, somewhere like that. And we want that area there, don't we? So that distance here is 9k, isn't it? Between k and 10k, taking them away. And then obviously the height here is pi over 20. So part A, nice and easy. Probability that x is less than 10k is equal to 9k times pi by 20. It's just the area of that rectangle there. So 9 pi over 20k. Now normally this would say and give your answer in terms of like k and stuff. It's a bit weird that it doesn't. Now let's just do part B. We'll come back and look at that in a moment. So part B show that k is 1 over pi. So the total area, so for 21 to to 1. So we got the length will be 21k minus 1k, and multiplied by pi over 20, and obviously the total probability is 1. So we've got 20k times pi over 20 equals 1. The 20 is obviously going to cancel there, so k equals 1 over pi. So as required. Now, if I go back to the first part of the question, I'll do this in blue, just alongside. So 9 pi over 20 times 1 over pi for k, that would give me the pi's would cancel, so 9 over 20. Very strange. I just double checked the mark scheme, just to be sure. So the mark scheme actually has the 9 over 20, but it doesn't say in terms of k, and this is like part B, which doesn't really make sense. I would assume that this would be part A and then this would be part B if you want that answer. You generally don't have like to work something out afterwards and then go back and fill it in. So that bit doesn't really make any sense. I think that's not a very nicely done question there. But anyway, we'll go on to part C. So I suppose in hindsight, I suppose just be careful. If it doesn't say like in terms of K, you might be worth putting in the actual answer with knowing that value of K, for example, in this case. Part C is find in terms of pi the values of E of x and the variance of x. So obviously this is a uniform distribution, and that is like a plus b divided by 2 is the mean. So a plus b are your two limits divided by 2. So you've got 22k over 2, so 11k. K is 1 over pi, so 11 over pi. And then variance of x is, now this is b minus a, so 21k minus k squared over 12. So 20k squared over 12. So k is 1 over pi, so we've got 20 over pi squared, so it's going to be 400 pi squared over 12. Or dividing by what, 4 goes into it, pi squared, so 100 over 3 pi squared. Hang on a minute, sorry, the pi was on the bottom, wasn't it? Because k is 1 over pi, so the pi is on the bottom, so just change that there. So that's part C. Circles are drawn with area A where A equals that. Find E of A. Now I'll just make a little bit more room before we go any further. So this looks like a bit of a weird one. We want to find E of A, but this is just simply one of those questions when, you remember like you had like say E of 3x plus 2. So that would be 3 times E of x plus 2. It's that type of question. Yeah. So we've got E of A, which means it's E of let me rub that out. It'd be pi times E of x plus 2 over pi squared. Now this means we've got a pi there, so E of, now the squared, so what you need to do with this is expand those brackets really. So this is going to give me an x squared plus, now it's 2 times these, isn't it? So x times this. So 2x over pi, so it's going to become 4x over pi. And then we've got 2 times, so it's going to be 4 pi squared. So that's what I'm looking at. So I've got pi times e of x squared plus, now it's 4 pi over pi. Shall I do this in 2 sets and a couple of different things? So I'll keep the pi on the outside first, just so that we can talk about it. So this is going to be then 4e of x so 4 over pi, that'd be the constant there, plus 4 over pi squared, and times everything by pi, we get pi times e of x squared plus 4e of x plus 4 over pi. Yeah, because some of those pi's will obviously cancel out. So we're looking good so far. We've got pretty much enough information here, and we got this information. So popping over, I'm just going to go into red over the side here. Remember that variance of x is e of x squared minus e of x all squared. So variance plus e of x squared is equal to this. Yeah, just taking that to the other side. So we got these two. So we've got variance is 100 over 3 pi squared plus 11 over pi squared, so 121 over pi squared. That is what my e of x squared is. Yeah. So now I can pop that into my question. So I've got pi times 1. Oh, I could actually work that out. Oh. I could simplify this in red first, couldn't I? It's 463 over 3 pi squared. As that just makes it a little bit easier over here. So 463 over 3 pi squared plus 4 times 11 over pi plus 4 over pi. So let's find that area. Just put it all in my calculator. Well, actually, before I put my calculator, if I put it in calculator, I get like 75 point something. So that's obviously, you know, a decimal answer. But if I wanted it exact, obviously this pi will cancel one of these pi's. And then this is now essentially, if I make it all over 3 pi, yeah, then what I've got is 463 over 3 pi. I got 44. So times that by 3 would be 132 over 3 pi. And then 4 times 3 would give me 12 over 3 pi. They're all over 3 pi now. So 463 plus 132 plus 12. So 607 over 3 pi. Okay, so that's one option to do this. I'm sorry, it wasn't 70, it was 64.4. That's the decimal answer there, and that's the exact answer. So obviously in this question it doesn't state, so either of these would be correct. Sometimes in a question it would state exact answer only kind of thing. Okay, so it's a nice one there. A little bit different with this one, but yeah, not too bad. Just recognising it when you first look at it, it looks a bit weird. Okay, next question. Company produces steel cable. Defects in the steel cable produced by this company occur at random at a constant rate of 1 defect per 16 meters. So we're looking at Poisson here. Because we've got, it's obviously occurring randomly at a constant rate. That's the important one. Now, 1 in 16. On one day, the company produces a piece of steel cable 80 meters long. So first thing I want to do, 80 divide by 16, yeah? So on average, I would expect there to be 5 defects. So that would give me, Poisson is like this distribution. Where Poisson, lambda is 5. Couldn't think of the name of it there. So find the probability that there are at most 5 defects. So at most 5 defects would be less than or equal to 5. So again, now easy, look up in the table or use your calculator. If you're using your calculator, you need to go to mode 7, unless you've got one of the newer ones. It's a bit more difficult to find them there. And then you want Poisson CD, which is number 3, X is 5, and lambda is 5. And that gives us 0.61596 or 0.616 to 3 significant figures. Now, if you want to use the tables, quite straightforward. Obviously, your lambda, you want your 5. I've obviously just got it next to them there. And then we'll highlight this in green. So you want less than or equal to 5. So here we are. So 0.6160, which, as you can see here, 4 decimal places, that is what we would have. Okay, so just as easy with the tables. Now, the company produces pieces of steel cable 80 meters long on each of the next 4 days. So this is kind of like as if it's switching into binomial now, which is quite common with these types of questions. A Poisson into a binomial or something similar. So find the probability that fewer than 2 of these 4 pieces contain at most 5 defects. So at most 5 defects is the probability that we've got. I'll keep it to 4 decimal places in my question here, but it's like part B now we're setting up. I will call this Y for binomial. N is 4 and the probability is 0.6160. Okay, I'll do it like that because it's the same as obviously my 3 significant figures, but it's also the same as if you use the tables there. And we've got to find the probability that for Y we had fewer than 2, so less than 2 containing at most 5 defects. So make it equals. So we're looking up less than or equal to 1 in either the binomial tables or your calculator. So in your calculator, if you use those values, from here you'd have 0.1613 to 4 decimal places. And even if you use the full answer, you would still get 0.1613. Just the decimals are slightly different, but the 4 decimal places, it would still be the same. In this one, I just looked and N doesn't start, it starts at 5, so you couldn't really use the tables on this one. But I think most of you use the calculators now anyway. Right, let's look at the next part of the question. The following week, the company produces a steel cable X meters long. Using a normal approximation, the probability that this piece of cable has fewer than 26 defects is this, 0.5398. Find the value of X. Okay. So let's break this down. It's x meters long. So in terms of our rate is obviously 1 defect per 16 meters. So we would have x over 16. That would be our value of lambda. Okay. Then for normal distribution, it's obviously mean and variance, isn't it? I'm going to just use x again here. So we're looking at normal. It's mean and variance, and they are both lambda, aren't they? Because that's what Poisson is. The mean and the variance are the same value. So that's what we've got as our initial setup. And we've got that when x, sorry, I'm just thinking. So x less than 26 is going to be equal to that 0.5398. Yeah. So now we just need to put in what this is in terms of a normal distribution. So in terms of z, that is x minus the mean. I'm just going to leave the x a moment, minus the mean over the standard deviation, so the square root of the variance. Now, we've got to be careful with the x here. We need to make sure we're using continuity correction. I'm trying to think, it's been a while since I've done stats. So we've got to make sure that we're using the right values. So for this, it would be 25.5. Because it's like less than or equal to 25, so it'd be less than the 20. It'd be the 25.5 then, wouldn't it? So that's the the bit in the middle. Just trying to rack my head with it. Might be worth watching my video on this just as a recap. But now we've got a set of values. Now I need to look up what this 0.5398 is in the tables. Now I'm looking up in the table just purely because we've got x in our mean and our variance, so it's a bit, you can't really, I don't think you can use the calculator on this section. But let me know in the comments if there is a way. We've got 5398 is here, so 0.1. That's my value of z, isn't it? So you've got now value of z. Let's move that out of the way. So that's going to be equal to basically z is less than 0.1. So this is just equal to that. So let's put that next. I can run out of room here. So 25.5 minus x over 16 over the square root of x over 16 is equal to 0.1. And really now it's just about rearranging this, isn't it? So 25.5 minus x over 16 is equal to 0.1 times the square root of that. I guess I would potentially square everything maybe. Let me just make a bit more room for this. Okay, so 16, obviously square root of 16 is 4. So what I've got here, 25.5 minus x over 16 is equal to, and 1 over 4 and 0.1 is 1/10, isn't it? So that's going to be 1 over 40 square root of x. Is that okay with everyone? So you square root, obviously the 16, so that gives you 1/4, and the 0.1 is 1/10, so they're 1 over 40. Okay, and so obviously I want to get rid of these fractions. Can't multiply by 40 because 16 doesn't go into that, but it does go into 80. So I'm going to multiply through by 80. This is just, you don't have to do this. It is just what I prefer. In fact, let me rearrange this first. So x over 16 plus 1 over 40 root x minus 25.5. So you could just put it straight in your calculator like this to solve this. It's a quadratic, but you've got x to the power 1, x to the power half instead. Okay, but I do like to multiply through. I hate fractions in stuff like this. So times by 80, this will give me 5x, times by 80, this will give me 2 root x, and times by 80, this gives me 2040. Okay, just double check that. Yeah. Now it's like a quadratic, can solve it. I would just use my calculator. I mean, I could have used my calculator from this step to be fair, but so we have 5x squared, 2x and minus 2040. So our values are, so this is obviously our values for root x. So they are 20 and minus 102 over 5. And obviously if I square them, so x would then become 400. And then the second one would just be impossible. I know you can square it and you would get a positive number, and I suppose square root in that would technically be right, but with these it should really be going with the positive ones. Oh, just noticed a little bit of a mistake there. But yeah, we just want the positive answer. So x is 400 here. And this is just due to the fact that we're dealing with just lengths. So there can't be any negatives in there. And that is the end of that question. Let's look at the last question then. Okay, final question. Continuous random variable x has a CDF, so it's cumulative distribution function, held by the capital F. Okay, which means that if we substitute in the upper limit, this will then total 1. So that's what we need to do for part A. So we want to do f of k. So we're substituting k into x. So that's going to be ak plus bk squared, and that's going to equal 1. ak equals 1 minus bk squared. And that was as required there. Okay, so using part B and given that e of x equals this, show this. Now, e of x is where we need f of x, don't we? And then we multiply it by x and integrate it. So f of x would be if I differentiated this. So it's going to be a plus 2bx, differentiating that. So e of x is integrating between k and 0, x times a plus 2bx dx, or ax plus 2bx squared. So it's ax squared over 2 plus 2bx cubed over 3 between k and 0. So that is a k squared over 2 plus 2 bk cubed over 3, and that is going to be equal to 6 over 5. Now, what I need to do here is get everything onto kind of one line, if you will. So, looking at this, I need to multiply by 6, don't I? And I also need to multiply by 5. So let's multiply through by, what should we say, 15? Will that do it? No. We need to multiply through basically by 30, aren't we? You can do it in one go then. So multiplying by 30, I would have 15ak squared plus, that'd be 10, so 20bk cubed, and 30, so 6, 36. So 36, the 15, but I'm wrong with the 20. Oh no, there's no A. Oh sorry, there's no A in this, is there? So I've got to substitute in from our first one. So we had AK if we look at the first one. So that'd be 15k times AK, isn't it? That's AK. So we got that. Sorry, I don't really need those bits of equals. And then that AK becomes 1 minus bk squared. I'll just make a little more room. That's better. So expand these. So we've got 15k minus 15bk cubed plus 20bk cubed equals 36. We're getting somewhere now. 15k plus 5bk cubed equals 36. And to get it in the form they want it, we'd have 5bk cubed equals 36 minus 15k. And that is done. Okay, so now we're going to go on to part C. Again, I'm going to make a little bit more room here now. Hopefully you've had enough time to see that. Now, part C. So this time we got use the variance. So what we've got so far, we know like AK equals 1 minus BK squared. And we've got 5BK cubed equals 36 minus 15k. And f of x was a plus 2bx, wasn't it? So that's what we've got. Now we've got the variance. So variance is going to be equal to 22 over 75. Yeah, so variance of x, so it's between k and 0, and it's this f of x times by x squared. So I'll just put it in one go. So ax squared plus 2bx cubed minus the mean squared. So 36 over 25, and that equals 22 over 75 there. Just get rid of this equals. So we have ax cubed over 3 plus 2bx to the 4 over 3. Sorry, it's not. It's over 4 between k k and 0. I'll take the 36 over 25 to the other side. That gives me 26 over 15. Now, on the previous question, when we substitute 0 in, because it was 0, I just didn't bother doing it. But it was a bit lazy, so I will do it on this one just to show you what you really should do in an exam. Okay, so obviously substitute your k in first. Just cancel that there. So we got pk to the 4 over 2. And then we substitute the 0 in. That's what I should have done. It was a little bit lazy of me not to do that. Okay, so I would do that normally. Now, looking at what we got on the bottom, 15, 3 goes into that, that's not a problem. Obviously 2 needs an even number, so making it 30. So we're going to multiply through by 30. So multiplying by 30 here, obviously 33 was 10. So we're looking at 10ak cubed plus 15bk to the 4 equals 52. Now, if you remember looking at here, there's no a in it again, so we have got to do the substitution with the ak from up here. So taking ak out of this first term, yeah, would leave me 10k squared on the outside of the brackets, and then 1 minus bk squared on the inside. Okay, that's obviously just ak there. We've got 10k squared minus 10bk to the 4 plus 15bk to the 4 equals 52. 10k squared plus 5bk to the power 4 equals 52. And they want it this way, so 5bk to the power 52, to the power 4 equals 52 minus 10k squared. And that is as required. Oof, that was a bit of work, isn't it? Just algebra manipulation, that's all we're doing here. Now, final part. Given that k is less than 3, find the value of k. Well, what we want to do is essentially look at, these two equations here. This is probably what's going to help us solve it, isn't it? So we want to do one equation divided by the other one. So like 2 divided by 1. Because that is 5bk to the 4 over 5bk to the 3 on the left hand side. 52 minus 10k squared over 36 minus 15k. So that's the first step. I can see 5's cancel, b's cancel, that cancels, just leaving a k. Now what I want to do is multiply up by this. So I've got k, that's what already left, just on the left side. 36 minus 15k equals 52 minus 10k squared. So 36k minus 15k squared. Just fill the rest of that in. And then let's just simplify. So add the 15k squared would give me 5k squared minus 36k plus 52. Okay, so all I've got to do here now is solve this quadratic. So you can use your calculator to help you out with this. You could complete the square. It'd be a bit more difficult on this. You'll use the formula, would be fairly easy. So we've got 5k and k. So this is going to be 26 and minus, and this one's going to be 2 and also minus. Yeah, so this then gives me 5k squared, minus 10k and minus 26k is minus 32, and then that's the 226 is 52, and obviously 2 minuses as a plus. Okay, but just to show, what I did is in my calculator, just to get the answer quickly, I put this into the equation bit. It gives me x equals 26 over 5 and x equals 2. So then I just thought, right, well, let's put that into a bracket. So look, 5x equals 26, 5x minus 26. And this will be x minus 2. Yeah, so x minus 2. And there's my two brackets. And of course, sometimes they are multiples of these. So, this obviously is the 5x squared. We've got k is what we're actually doing. If it happened to be, 10, then one of these brackets would need to be double the size. And that's all I did, just to factorize it quickly, Now, so k equals 26 over 5, k equals 2, and 26 over 5 is 5.2, so we don't want that one, we just want the k equals 2. And once we've got k equals 2, we can go ahead and find our values of a and b. Yeah, so all we're going to do is use one of the previous equations now. So you've got the first equation here, can substitute into it. So this one now becomes, I'm going to do this in red up here. So k is 2, so it becomes 2a equals 1 minus 4b. So that now is a new equation. I'm going to call that equation 3. And then out of the equations I've got left, I want to use the easiest one. So first start with 1. I'm going to do it from 1 over here. Because obviously 1 and 2, they both just got b, haven't they? So 1 would be k cubed, so 2 cubed is 8 times by 5 is 40b equals 36 minus 30. So 40b equals 6, b equals 6 over 40, or 3 over 20. And then once I've got that, I can use equation 3, which I created. So 2a equals 1 minus 4 lots of 3 over 20. So 2a equals 1 minus 12 over 20. So what's that? 8 over 20. So a is 4 over 20. Okay, and there are my two answers for a and b. Oh, and I almost forgot to simplify there. Here, so it's actually a equals, let me rub out that line, because 4 over 20 is actually 1 over 5, isn't it? So there we are, 1/5. Hope you've enjoyed this video and you found some use out of it. Okay, don't forget to like and subscribe. Comment if you feel you want something to say, ask me any questions, or just say thank you. And there'll be this 2023 series is going to be ongoing, so there will be every paper in this 2023 series will go online, after which then I'm going to be putting together some hardest questions series, so from the last few exams that I'm allowed to put questions up for. So stay tuned for all of those coming soon.